Hey guys, in this video we will analyze projectile motion using three graphs: position versus time, velocity versus time, and acceleration versus time. So let's get right into the first one, position versus time. I have all these graphs broken into their x and y components to make the motion easier to visualize. So let's start with the delta x graph. So we know that delta x is equal to VOT plus 1/2 AT squared. But we also know that acceleration is 0 in the x component in projectile motion. Therefore, this entire term gets cancelled out, so we can see that delta x varies linearly according to time in projectile motion. So we can quickly graph here the delta x over time graph, which would just be a linear graph. Now let's quickly head on over to the delta y graph. Delta y, differently from delta x, the acceleration will not be 0. It will actually be negative. So we have negative 1/2 gt squared. So since d squared, it varies following like the shape of a parabola, and since the t is negative, the first term is negative, the parabola will be upside down. So the delta y versus time graph will look somewhat like this. And that is mainly it for the position versus time graphs. They're very self-explanatory. Let's get into the velocity versus time graphs. So these are again broken into their x and y components. Now, the velocity versus time graph for the x component will also be very simple, because we know that since we know that acceleration in the x direction is equal to 0, but the velocity versus time graph will be constant. So let's say initial velocity is somewhere around here. If we trace the graph, we know that final velocity is equal to initial velocity. So we can just trace a line that is just constant. So velocity in the x component does not change, and this is for t final, time t final. This is the same point. Now let's look at the velocity in the y direction versus time. So now there is an acceleration here, and the acceleration is negative 9.8 meters per second. And actually, the acceleration is the slope of the velocity versus time graph. So let's say our initial velocity is somewhere around here, VOY. Since the slope of this graph, which will be linear, because it is velocity is equal to negative 9.8 t here. I'll draw here really quickly a linear function that will go below the x-axis, or the time. Why? Because again, if we're looking at a projectile motion and only analyzing the y component, the object goes up and comes down. So the velocity the initial velocity will be VO. It will go up, and at its maximum height, the velocity will be right here, which is 0. This is the maximum height, this point. And then it will keep going until it falls down at this point, at a t final, sometime t final. And an important thing to notice is that this final velocity is just the negative initial velocity, so negative VOY. That is the final velocity, and that is mainly it for these graphs. Last thing to realize, however, is the area under the graphs. So this area right here, and these areas right here, they mean something. So if I had to ask you guys, what is velocity multiplied by time? Well, velocity multiplied by time, let's analyze this for a second. Velocity is in meters per second. Time is in seconds. Multiply those two, you get meters per second over seconds, cross that out, so you just get meters. So if you were to find the area under this graph by multiplying the height, VO, by the time t final, you actually get displacement in the x direction. And here you would also get displacement in the y direction, but since this area is going to be positive delta y, and this is going to be a negative delta y, and they're equal but opposite, they will cancel out, so therefore the displacement here will be 0, and that is consistent with what we see in projectile motion in real life and everywhere. So now let's head over to acceleration versus time. So we know that in the x direction, acceleration is 0. So we just draw this right here until a time t final, and there's that. And then we know that for the y component, that acceleration is going to be negative 9.8 or negative g. I'll just put a negative g here, and that will be its acceleration for the entire motion, because as we know by now, in projectile motion, acceleration is constant. In kinematics as a whole, acceleration is constant for all that physics 1 encompasses. So this acceleration will be constant. And this is a time t final. Now again, let's analyze these graphs a little more and think about the area under the curve. So this area right here. We're looking at this rectangle, and we see that the height is acceleration and its length is time. So what is acceleration multiplied by time? Dimensionally speaking, we have meters over second squared multiplied by seconds. That will give us meters per second over second squared. Cross out one of the seconds, we just get meters per second. Therefore, the area under this graph, or the area under this curve, the area of this rectangle, would just be velocity. And that is mainly it for these graphs. You can think about them a little bit, make sure you understand what they mean, what they're representing, because it will really help you in the AP exam or whatever test that you're taking for physics. And that will be it for this video. I hope to see you guys next time.